Hi, this is Mr. Rutherford. In this problem, we will learn to find factors of a polynomial. Show that 2x minus 1 is a factor of 6x cubed plus 23x squared minus 5x minus 4. Then find the remaining factors of the polynomial. So here we have our polynomial 6x cubed plus 23x squared minus 5x minus 4, and we'd like to see if 2x minus 1 is a factor of this polynomial. So we're going to write this as a quotient, dividing our polynomial by 2x minus 1. What I'm going to do first is get a coefficient of 1 for our down here in our denominator for the x. I can do this by dividing the bottom by 2, but if I do that I also have to divide the top by 2 to keep it balanced. The result will be, when dividing the numerator by 2, 6x cubed divided by 2 will give us 3x cubed. And we'll do this with each term, so we'll have 23 over 2x squared. Then we have minus 5 over 2x, then minus 2. And this is all over 2x divided by 2 will be x, and then minus 1 half. Because we have x minus 1 half, what we can say is that 1 half is a 0, because 1 half minus 1 half is 0. So we're going to use this 1 half in synthetic division to find out whether or not 2x minus 1 is in fact a factor. So we'll set it up here with our 1 half. Then we're going to write the coefficients of our new polynomial. Our coefficient of x cubed is 3, of x squared is 23 over 2, then of x is negative 5 over 2, and our constant here at the end is negative 2. Now my first step is to bring down the 3, and we're going to multiply 3 by 1 half, which gives us 3 over 2, or 3 halves. Then we're going to add 23 over 2 and 3 over 2, and this will give us 26 over 2, which is equal to, when simplified, 13. So now we'll bring the 13 and multiply it by 1 half, and we get 13 over 2. Then we'll add negative 5 halves plus 13 over 2, and this will give us 4. Then we'll multiply 4 times 1 half, and we get 2. Then add negative 2 and 2, and we get 0. So in other words, we have a remainder of 0. This means that 2x minus 1 is a factor of 6x cubed plus 23x squared minus 5x minus 4. Now we need to find the remaining factors of the polynomial. So now I'll rewrite this as 2x minus 1 times, and here we have a 3, so we'll have 3x squared. Then we had 13, so plus 13x, and then we had a 4, so we'll write plus 4. Now what we need to do is we need to factor 3x squared plus 13x plus 4 to find the remaining factors of this original polynomial. We know that 2x minus 1 is a factor, so let's factor the 3x squared plus 13x plus 4. I'm going to do this by first writing the factors of 3. The factors of 3 are 3 and 1. Then I'm going to list the factors of 4. We have 4 and 1, 1 and 4, and we have 2 and 2. Notice here on the left, I only wrote 3 times 1 as opposed to writing 1 times 3 as well. as opposed to here on the right, I wrote 4 times 1 and 1 times 4. So what I'm going to do is multiply 3 times 1, and this is equal to 3. 1 times 4, this is equal to 4. And the question is, when I add 3 and 4 together, can I get the coefficient of x, which is 13? Well, the answer here is no. This means that 4 and 1 will not work. So now I'll check 1 and 4. So we'll do 3 times 4, which gives us 12. 1 times 1 is 1. If we add these together, does this equal 13? And the answer is 13 does equal 13. So these are going to be the terms of our new product. So what we'll have here is the product of two binomials. So we have 3. This is going to correspond to 3x. Then we have 1 here on the right, which is going to correspond to plus 1. Then we look at the second factor of 3, which is 1. This is going to correspond to x. Then we look at the second factor of 4, which in this case is 4, so we'll have x plus 4. So this is our factored form of 3x squared plus 13x plus 4. And now I'll bring down the 2x minus 1. So now we have 3 separate factors of our polynomial 6x cubed plus 23x squared minus 5x minus 4.